ஸ்கோப்பால் ஆகாதெனினும் விட்டுத் தள்ளு closures கூலி தரும். வணக்கம் brothers. So this week we'll be visiting this topic called closures. It's an important interview topic for especially JavaScript interviews. என்னடா திடீர்னு இங்கிலீஷ்ல பேசுறானேன்ட்டு பதறாதீங்க. Since this is a lot of technical terms involved in the video, I choose to go the English way. Let's not delay any further and jump into the content. So to understand closures, we need to be clear about scoping and hoisting. So let me first deal with hoisting. I'm trying to print this. So I have this extension called nodemon, which will run the file whenever it's changed. Okay, run the JavaScript file whenever it's changed. Okay, so 2 undefined and 4 var a I have declared at the top and trying to console log. Of course a will be printed, there's nothing wrong in that. And b is undefined. It shouldn't be, because it should throw an error because we are trying to use it before we are trying to declare it, but that's how JavaScript works. And function, we have declared it after it's been called, but even though it's returning 4 and the 4 is being printed there. So why this is happening? It's because of hoisting. What hoisting does, it shifts all the vars and functions to the top of the global scope. So this is what we call a global scope. So everything is shifted to the top except the vars. The values won't be assigned until line number 3. The value of b won't be assigned until line number 3, but b is available global scope, but it has value undefined. So what if we change it to const and let? So that's where const and let come into play. Const and let do not come under the hoisting phase. They have something called TDZ, temporal dead zone. Dead spelling wrong. Temporal dead zone. So what we are trying to, cannot access b before initialization. This is what we prefer over something like this. This will give ways to more bugs compared to this, whereas this will block most of your bugs because you know where the problem is coming from, and it won't happen in the first place. And what if we declare it as an arrow function, const d equal to, so this is an arrow function now. Okay, so both of them is going to throw an error even if this comes. Yeah, d cannot access d before initialization. So according to JavaScript, this is not a function, this is just a variable. Arrow functions and function expressions are just const and let from the POV of the JavaScript compiler. Yep. So now what is scoping? Of course you know about scoping, everyone knows about scoping, but how scoping works in JavaScript. So there's this repo of mine I wrote a couple of years back. I'll drop the link in the description, no problem, and we'll look at this piece of code. I'll try to run this piece of code here. VS Code, run my new, and I should be calling the second function here. So as you can see, the C is already blanked out here because VS Code knows that this C is going to be used nowhere. You can argue by saying in line number 7 we use C, but no, this C is not referring to this C because this C is not available in the third function. Let us see. Error. Boom. The reason is that third is being called here first, the second function is called, and on top of that the third function is called, and after the third function is returned there's nothing after that. Maybe a console.log high from 2. So instead of this we console.log high from 3. So this high from 3 is going to be printed first and high from 2 is going to be printed at last, because first the second function is called, line number 2 is read, there's this variable declared in the scope of this function alone. This is function scope, not the global scope. So global scope is this, function scope is this one, and this has its own function scope. And what is block scope? Block scope is available like this: if 3 greater than 2, const 4 equal to 4. So this is called a block scope. So this const 4, if we try to refer it here, console.log 4 this will throw an error because block scopes are specific to only the block. Okay, so coming back to this, second function is called first. And then on top of the second function, the third function is called, and after the third is returned, it comes back to the second, compiles the fourth line and executes the fourth line, and then this is returned. So from line number 11, it goes to line number 1, 2, 3, 6, 7, 8, 9, and then 4, 5, back to 11. The numbers I've listed right now looks like the scoreboard of RCB, but okay, fine, that's the topic for another day. Let's proceed with the closures. So let's try to remember what are first class functions. I've said it earlier in another video of mine, but here we go again. First class functions are functions that return a function. Okay, so this greet, this is the parent function. It returns another function. In line number 6, what happens? First, I'm calling gray with an argument hey. This argument goes and sits in this parameter greeting. So greeting becomes hey, and this Mahesh is getting called here. Like this, you have to visualize it. Okay. So this Mahesh goes and sits here name, and it's going to be printing hey Mahesh. Yep. And let me come to this line. It's the same thing happening here, except we are storing the function which is returned in a variable, and then with that variable we are calling the function. Okay, it's like this function, we are naming this function as inner, which is already preloaded with an argument hi, and we call it again with Kevin Durant. Let me make it hey. Yep, hey. Yep. But how are closures related to this? What are even closures? Let us Google closures. Is a combination of a function bundled together with references to its surrounding state. In other words, a closure gives you access to an outer function scope from an inner function. So what's the inner function here? This is the inner function. What's the outer function here? This is the outer function. Outer function scope. Let's say there is a variable called let something equal to 0, and if we try to refer the 0 here, oh no, I'm sorry, 0 0, we can access the parent scope from the inner function. Okay, so again, this is normal. What's special with closures? Let me show you. Consider this piece of code, for example. It's the same thing. This is the inner function, this is the outer function. This booker, what's the booker, what is contained, is going to contain whatever secure booking is going to return. And what secure booking is going to return? It's going to return a function. So this is going to come and sit here, except if we do it like this, this doesn't know what passengers are. Okay, now if I call booker, it's not going to, because passengers is undefined according to this. But whereas if I do it like this, and if I call booker 1 passengers, so what happens here? Passengers is declared as 0. It returns a function. That function goes and sits here in booker. That function is being called, and then if we increment passengers, we still have access to the outer scope variable. That's the point of closures. And there's much more interesting thing. The value keeps on increasing. It doesn't get reinitialized to 0. Okay, because line number 2 is read only once. Because in line number 8 we are calling the function, so it goes back to line number 1, and line number 2 is read once, so the let variable passengers is declared as 0, and then this function comes and sits here, and every time we call the booker function, the value keeps increasing because this still retains the right over this variable. That's called closures. It's when like you're kicked out of the home and still you have the room key. When you think of it, this mode of programming is highly secure because you have access only to the inner function and not the outer function. You can't touch this variable. You can only call the function which alters the variable according to the function. You can come here and say passengers equal to 100. This passengers won't be affected just because you declare the same named variable here. That's different. So this is next level. Okay, this is called closures, and it's an important topic. So see you in the next video. Welcome, brothers.